It's me, Divyanshu from class 8th standard, going to present the PPT on metals and non-metals. So, there are different types of metals, different types of non-metals, and some other chemicals, some other elements. So, my friends will describe briefly about metals and non-metals in the upcoming PPT. Thank you, and now I would invite Suma to explain about metals and non-metals.
Hey friends, my name is Suma and I am from 8th standard. I am going to explain classification of elements. So, classification of elements means there are about 115 elements which are using now. So, we can't say easily or describe it easily. So, our scientists classified it into group. So, we can say elements are classified into metals, non-metals and metal. So, metals, those materials which are hard, lustrous, malleable, ductile, these are the metals. Non-metals, those elements which are non-lustrous, non-malleable and non-ductile are non-metals. Non-metals can accept electrons and the electronegative interaction. So, metalloid is a chemical element that exhibits of the property of metals and non-metals is known as metalloids. So, they are the non-metals boron, silicon, germanium, arsenic, antimony, tellurium and polonium are metalloids. This is periodic table of the element. So as I said, scientists divided into groups and periodic. That periodic is known as periodic table. Example, helium, lithium, beryllium, etc. In this, they are divided into groups you can see. So, thank you. My friend Afsa will explain you about metals and non-metals.
Good afternoon everyone. As my friend told that she explained about metals and non-metals. So I am going to explain briefly about metals and non-metals. So these are the items which we use in our daily life. So examples are lead, tin, gold, platinum and copper. These are the materials or metals which we are using in our daily life. So here metal is a chemical element that is a good conductor of heat and electricity to form cations and ionic bonds with non-metals. So here is nothing but the metals which produce heat and electricity as well. So by this combination they form an ionic bond and which with non-metals. A metal from Greek metallion minerals is characterized by high electrical conductivity. In a metal atoms readily lose electrons to form and positive ions. So this metal word came from the Greek characterized by the electrical conductivity. And here those icons are surrounded by the dipolarized electrons which are responsible for the conductivity. So here the surrounded dipolarized electrons are responsible for the formation of electric conductivity. So the examples of metals are iron, copper, gold, platinum, magnesium, sodium, etc. So my next topic is non-metals. So these are the metals which we use in our daily life but not in daily life. So we will see examples carbon, phosphorus and sulfur. These are the examples of non-metals. So non-metal is a chemical element that bad conductor is both electricity and heat. So here non-metal is nothing but it is a chemical element which is a bad conductor of electricity and heat, and by this they forms an ionic bonds with metals. Non-metals are readily accept electrons to form negatively charged ions or anes. These examples of non-metals are sulfur, carbon, oxygen, phosphorus, hydrogen, oxygen, nitrogen. So here is nothing but the examples of non-metals are sulfur, carbon, oxygen and phosphorus, etc. So now my friend Muskan will explain about the properties of metals and non-metals.
Hi friends, my name is Muskan. I am from 8th standard. Today's my topic is physical properties of metals and also non-metals. Question: physical state. All metals are solid at room temperature except mercury, which is liquid. Here they are saying that metals are solid in the normal temperature, which is not room temperature, except the mercury, which is liquid formness. Hardness. Most metals are very hard. They can withstand the high pressure without getting disordered. But metals such as sodium and potassium are soft metals and they can be cut by hand. And metals are hard. As we know, they are very hard and have a high force, which are very high pressure. So they can't get any damage when we are having a high pressure, except the potassium and the sodium. Because they are soft metals, they can be cut into different parts by the knife. Density. Metals generally have high density than non-metals. That is why they are very hard. We can say that metals are very hard because of the high density, and the non-metals have low density. That's why they are not that hard than the metals. Tensile strength.
Good afternoon everyone. My name is Ishamani and I am from 8th standard. So my topic is chemical properties. Metals and non-metals differ each other in their chemical properties. They show different chemical changes. So with the chemical properties of metals and non-metals, we can find the difference between metals and non-metals. So they show their chemical changes. In their properties, they show their chemical changes. So let us compare the chemical properties of metals with those of non-metals in terms of their reactions with the following. So let us compare the chemical properties of metals and non-metals with the following reactions. Those reactions are reaction with oxygen, reaction with water, reaction with acids, reaction with alkalis. So the topic is chemical properties of metals. Reaction with oxygen. Almost all metals react with oxygen to form metallic oxide, but their reactivity is different. So here they are saying that all metals, here we have many metals like Apsa said, we have more metals. So with the help of oxygen, with the reaction with oxygen of metals with the oxygen, so they will make a form called metallic oxide. So here the metallic oxide is formed by combination of metal and oxygen. We get metallic oxide. Sodium and potassium are the most reactive metals. They vigorously react with oxygen in air at room temperature to form sodium oxide and potassium oxide. That is why sodium and potassium metals are sold under kerosene or in Vaseline to prevent their reaction with oxygen and water. So here sodium and potassium are the most reactive metals. These two are the most reactive metals and they are combined with oxygen to get sodium oxide and potassium oxide. By mixing the combination of sodium and oxygen, we get sodium oxide, and potassium oxide, potassium and oxygen, we get potassium oxide. Similarly, other metals also react with oxygen to form metal oxides, but their reactivity decreases in order. So here they are saying that all other metals are also reactive with oxygen to form metallic oxide, but their reactivities are decreased in order. So here the next reaction with oxygen is the other metal called calcium. So calcium is combined with oxygen and form calcium oxide. Recall the activity in which magnesium ribbon burns with a dazzling white flame to form a white powder. So here magnesium ribbon is burned with a dazzling white flame and forms a white powder substance called magnesium oxide. This powder, when reacted with water, it forms a base magnesium hydroxide. So here, when a magnesium ribbon is burned with a dazzling flame, it forms a white powdery substance, and that white powdery substance is called magnesium oxide. So this powder, when this powder is acted with water, it forms a base called magnesium hydroxide, which turns a red litmus in paper into blue. So as we know, in previous chapters we have learned that if red litmus is going to turn into blue litmus, then that reaction is known as basic in nature. So magnesium is combined with oxygen, so this forms magnesium oxide. So here aluminium is also a metal in which is react with oxygen to form aluminium oxide. This oxide layer is a protective coating on the surface of aluminium metal and prevents the metal from further corrosion. So here aluminium metal. It is a metal, as you know it is a metal, and it is also reacted with oxygen. It forms a reaction called aluminium oxide. So if this is an oxide which is a layer to protect coating of the surface of aluminium metal. So we have aluminium metal, right? So we on those metals, aluminium metals, we use aluminium oxide to a layer to protect the aluminium metals. So and prevent the metal from further corrosion. So to also not to protect the aluminium metal, to prevent the metal from further corrosion. So aluminium is combined with oxygen is resulted as aluminium oxide. Iron metals reacts with oxygen and moisture present in the air to form a brown colored flaky substance on its surface. It is called as rust. Iron oxide. So this is layer by layer destruction of iron metal called a rusting of iron. So iron, as you know, iron is also a metal. So it is combined with oxygen and moisture present in the air. So it will form a brown colored flaky substance called rust. So when we see iron metals combined with oxygen, some of the rust brown substance will come out from the iron. So that is called rust. So here iron plus oxygen plus water vapor which is present in the air. So iron, oxygen, water vapor is known as hydrated iron oxide. It is present in the air. So this oxide is present in the air. If we take a small amount of sample of rust and dissolve it in water, we will find that rust dissolved in water and the solution basic in nature. When checked with a moist red litmus paper, its color changes blue. This shows that its solution is basic in nature. So we know that here we have rust, right? The brown flaky substance is rust and it is dissolved in water. This solution, the dissolution in water, those water substance is known as is basic in nature. When we check the moist of the red litmus, when we put that liquid on the red litmus, if it turns to blue, then we have confirmed that it is basic in nature. Copper metal also undergo corrosion in moist air. When a copper vessel is exposed to moist air for long, it occurs a dull green coating. The green material is a mixture of copper hydroxide. So copper metal, if we put a vessel, for example, if we put a vessel on moist air for a long time, it occurs a dull green coating. The green material is a mixture of copper hydroxide. This dull green coating is the mixture of copper hydroxide and copper carbonate. The mixture of copper hydroxide and copper carbonate, these dull green coatings are formed. It is called as basic copper carbonate. The following is the reaction. So this is called basic copper carbonate. So this is the formula that we use for the solution of basic copper carbonate. Metal oxides are called basic oxides because these oxides react with water to form metal hydroxide, which are bases. Metal oxides are also called as basic oxides because these are if they react with water, they will form metal hydroxide. For example, metal oxide plus water, metal hydroxide. Magnesium oxide plus water, magnesium hydroxide. Calcium oxide plus water, calcium hydroxide. Metal hydroxides bases which dissolve in water are called alkalis. So those bases which dissolve in water are called alkalis. Bases which dissolve in water are called alkalis. Sodium hydroxide, for example, sodium hydroxide and potassium hydroxide. All nonmetals react with oxygen to form non-metallic oxide, but their reactivity is different. Nonmetals react with oxide to form non-metallic oxide, but their reactivity is different. So here, non-metal plus oxygen is equals to non-metal oxide. For example, sulfur plus oxygen, sulfur dioxide, carbon plus oxygen, carbon dioxide. Nitrogen plus oxygen, nitrogen dioxide. If we combine oxygen with non-metals, this reaction which will cause dioxides. Phosphorus burns vigorously with oxygen to form its oxide. For example, phosphorus plus oxygen is equals to phosphorus pentoxide. The phosphorus is in which only phosphorus burns vigorously to form its oxide, to form its oxide. For example, it is phosphorus pentoxide. Generally, oxides of non-metals are acidic in nature. Non-metals oxide react with water to form respective acids. So the metal oxides are also called acidic oxides. So the non-metal oxides turns moist blue litmus paper into red. In metal oxides, red litmus turns to blue, so it is basic. In non-metals, it is blue litmus turns to red, so it is acidic in nature. Non-metal plus water is acid. When sulfur dioxide is dissolved in water, it forms sulfurous acid. The reaction can be given as follows. So this is the reaction to form sulfurous oxide. The sulfurous oxide, the sulfuric acid turns blue litmus paper to red. Carbon plus oxygen, carbonic acid. Sulfur dioxide plus oxygen, sulfuric acid. Thank you. So, next my friend Vignesh will explain the reaction of metals and non-metals with water.
Sure.
It's me. I am Shani from 8th class. So today I am going to explain chemical properties of metals. So reaction of metals with water. Metals react with water to form metal hydroxide and hydrogen gas. The reactivity of metals with water is different with different metals. Hydrogen gas is evolved during the reaction which burns with the oxygen. So we know that metals react. Metals are so many types and the reactions are also so many types. If the water is cool, the hydroxide will be released, and if the water is in hot temperature, then the hydrogen gas is produced. So the relativity of metals with water is different with different metals. So as we know that metals are so many types and the reactions also are in so many types. So hydrogen gas is evolved during the reaction which burns with the pop sound. So when the hydrogen gas is evolved, the sound will be like pops. So metal plus water is metal hydroxide plus hydrogen gas. Metals like potassium and sodium react vigorously with cold water. Sodium and potassium metals react vigorously with cold water to evolve hydrogen gas, which immediately catches fire, producing a lot of heat. These metals dance on the surface of water. So here is nothing but metals like potassium and sodium, which is react in huge amount. So then with the cold water, because the cold water, the metals which react with cold water, they produces the hydroxides. So sodium and potassium metals react vigorously with cold water, because if it reacts with hot water, they will produce hydrogen gas, which is so dangerous and which catches fire in lot of heat. These metals dance on the surface of water. It means it will not in unstable of position. Potassium plus water, potassium hydroxide plus hydrogen gas. Sodium plus water, sodium hydroxide plus hydrogen gas. If it is mentioned as cold water, we can say that it's a potassium hydroxide. If it is not mentioned, we can say both. So this is the reason why sodium and potassium metals are kept in under kerosene or vaseline in order to cut off their contact with water and atmospheric oxygen. So sodium and potassium metals kept in kerosene or vaseline to prevent the production of hydrogen gas, which catches the fire immediately.